Hi everybody, welcome to Thursday. Today we're going to be looking at polymers and we're going to be dissecting a diaper. My name is Kathy.
And I'm Peter.
And we're going to be working together to show you how to do today's activity.
Wet diapers. Wet diapers have been a problem for parents for a very long time. How do you keep a baby dry until they're old enough to potty train? Modern engineering has made this easier for us by using chemistry to engineer a solution. Disposable diapers are very absorbent because they contain chemicals called hydrogel polymers. Polymers are large chain molecules made of smaller units called monomers. In fact, if you break the word polymer down, it means many poly units, mer. Look carefully at the picture of this polymer. Can you see the monomer? It's right here, and here, and here, and that continues until you get to the end of the chain. The repeating nature of a polymer gives it many of its properties. Living things are made mostly of polymers. They make up our muscles and bones, our organs and our brains, even our DNA is a polymer. But hydrogels are synthetic or man-made. We have copied the patterns of nature to make polymers that solve human problems. Hydrogels react with water. When water is mixed with hydrogel chains, the water creates crosslinks. The water molecules are held between the chains, and this holds the chains together. Because different polymers are made of different monomers, not all hydrogels react in the same way. Today we're going to observe 3 polymers and experiment with polymers in diapers.
Activity is kind of messy, so Peter and I are going to be working outside to protect everything and make sure it's easy to clean up. One of the things you can do is lay down newspaper, but if you don't get a newspaper, then what you can do is take a plastic bag and just kind of open it up on your workspace so that everything is easy to clean up. So these are the things that we need for today's activities. You should have 2 diapers unless there are 3 children, in which case you'll have an extra diaper. You need polymers A, B, and C. C is actually in a little tube. You're going to need salt a little later in the activity and some measuring cups if you have them. And they don't have to be the same size. We only have 1 set of measuring cups at our house, so we have two of the different sizes. We have 2 gallon bags because it's just me and Peter, and we're going to be comparing our diapers. We have 1, 2, 3, 4 medicine cups. We have our journals so that we have stuff to write, so that we can have a place to write down our observations. And then we have a pair of scissors, which are optional. If you don't have scissors on hand, you can do the activity without them. Okay, so you can see all of our polymers in our different cups. Now, there is actually enough polymer that if you have some other small cups and you want to separate them out, each person can play around with their own polymer.
Observation is a very important part of science. You use your senses to gather information about what it is you're trying to examine. You're going to use your senses to examine these 3 polymers.
We have all of our polymers set up so that we can do some observations. We're going to observe what we see, what we hear, what we feel, and what it sounds like when we move them around. And Pete, why don't you start out and let's take a little bit of powder A, and we're going to put it out on the bag so that we can take a look at it. And we're going to do some observations.
For each of your senses, write 2 observations for each polymer. Pause the video now and go ahead and observe each of your 3 polymers.
Now you also have a 4th medicine cup, which Pete has filled with some water. He's filled it up to 25 milliliters, and you can choose whatever amount you'd like. And he's going to add it to medicine cup for powder A. So go ahead and do that, Pete.
Have your data chart ready once you add the water because you're going to see some changes occurring. Remember that what makes this scientific is the quality of the observations that you make, so please make sure that you're paying close attention to what happens when you add the water to each of the powders. Now go ahead and explore. What do you see when you add the water? Add a little bit more water, stir with your finger. Eventually allow the polymer to sit in the water for about 5 minutes and make your observations again. Has anything changed? Record your observations in your chart. Once you're done, see if you can figure out which of these powders is used for which function. One of the powders is instant snow. One of them is used by florists because it absorbs water slowly, but it also releases water slowly. One of them is used in diapers. Can you tell which powder is which? Write what you think on the bottom of your chart.
So the first thing we want to do is take a look at the diaper and just analyze how it's put together so that we understand why it's been designed the way it has. So if you look, for instance, you can see that there's a little bit of stretchy elastic here. Why do you think that's there? And we've got some tabs over here and a little bit of Velcro here, and it's kind of padded. So go ahead and take a couple of minutes, and in your journal, you want to write down what you see, draw a picture of the diaper, and you can even name what these things are and decide why they've been engineered that way.
Each camper should have their own brand of diaper to examine. Remember that you're looking at the design of the diaper, but you're also looking at the materials it's made of. For right now, we're going to leave the amount of powder from the lining blank. So go ahead and pause the video and examine your diaper and the way in which it's been engineered.
So this is the lining, and this is the part where we find most of the absorbent materials. So what you're going to do, you can use scissors to do this, but again, it's not necessary. And you can see I'm just kind of pulling it apart so I can see what is inside. And yes, we're going to destroy the diaper. So if you look in here, you can see there's some powder in here, and there's a whole bunch of cotton and some other things, and I can also see that it's kind of stuck in here, so I'm going to pull this apart. Now, I don't want to lose any of these materials, so I'm going to take the baggie that I've been given, and I'm going to take these materials as I pull them apart. And here I'm going to pull them apart, and you can see I've lost some of the powder over here. I don't want to do that. And I'm going to pull it apart and start putting the pieces, all of the pieces, into the baggie. So just like this. Okay, and you want to continue until you have dissected, pulled apart into all its pieces, all of the parts of the diaper.
So now we're ready for you to disassemble your diaper. You're going to dissect it and pull it all apart in the bag. You want to make sure that you get as much of the powder out of the diaper as possible. This is the super absorbent polymer.
So remember that Pete and I did two different diapers. So we have diaper A, which was Huggies, right here in this bag, and we had diaper B, which was Parents' Choice, in this bag. And so we're going to do a little comparison to see which one is going to absorb the most water. Okay, so we're ready to start testing out our first diaper. So we have water in a large pitcher, and we actually have a measuring cup that we could use, or you can use your medicine cups. And Pete and I decided that we were going to use our medicine cup. So Pete, you want to go ahead and add our first 30 milliliters and mix it up. Just pour it all in. Mix it up with your hands or shake it up. Is it all absorbed?
Yep, I think it is.
Okay, so the next thing that we're gonna do is we're gonna record on our data chart that we have added 30 milliliters.
Each time you add water, you're going to add that amount onto your data chart.
Okay, so I have now written down that we have used 30 milliliters of water. And Pete, are you ready? We're gonna add another 30. So go ahead, add another 30 to your bag, mix it up. Is it all still absorbing?
Yes, it is.
Excellent. So we are going to go ahead and we're going to record 30 milliliters again on our data chart. And we are going to continue adding water to our polymer until it will not hold anymore.
Are you ready to test your diapers? You have either 2 or 3 diapers to compare. And what's very important in keeping this scientific is that you need to make sure that every diaper gets water that is added in exactly the same way, in exactly the same amount. Each time you add water, you need to try and mix it exactly the same way. This is what makes it scientific. You're going to continue adding water to the powder in the bag until the powder can't hold any more water. And at that point, you should stop. When you are done, look at the total amount of water that you've added to each of the diaper. Which diaper brand absorbed the most? Rank the diapers with 1 being best and 3 being worst. The last thing that you need to do is what all good scientists do, and that is to report your findings to other scientists. So go on the Facebook page and tell everyone else what your family found. Compare your results with the results of others. Did they find the same thing? What might you have done differently to account for differences that you might see? This is what good science does. I hope that you've enjoyed doing this investigation of polymers, and keep in mind that there are other scientific experiments that you can do with these polymers. So be creative. If you want some extension activities that you might be able to do, go ahead and meet with one of the counselors for STEM Family Camp, show them what you found, and ask them what other things you might be able to do. Well done, scientists. We'll see you tomorrow.